Hello, good afternoon, ma'am.
Good afternoon, sir.
First of all, I thank convener of FDP, Dr. R. Kiran Kumar, to invite such a eminent resource person, Bharati Devi Garu, to this wonderful session. Madam is familiar in several domains. He done his research in KRISHNA University. Now he is doing in Government Degree College. Okay, he is familiar in data analytics and its applications. He is familiar in several domains. Okay, thank you, ma'am. Just to start your session, ma'am.
Sir, can you hear me?
Yes, ma'am.
Yes. Thanks for nice introduction, Prakash sir. A warm welcome to all the participants for this faculty development program. First of all, I would like to thank my gurus, Professor Y.K. Sundar Krishna Garu, Dr. R. Kiran Kumar Garu, Dr. M. Babu Reddy Garu, and Dr. Vijay Kumari ma'am for giving me this opportunity. So I thought that always the session at post lunch seems to be difficult to pay attention, but I will do my best to grab your attention. So at the end of this session, you will able to learn, or you will able to understand what is data, what are different types of data formats, as well as you know about data analysis and data analytics, and also you will be able to understand the differences between data analysis and data analytics. And one more thing, you know about what are various types of data analytics. So, and also the most important one is what is the life cycle of data analytics. There are 6 phases, and also you will learn by the end of the session. And my session will be end with a case study. It's a diabetes prevention. Okay, so before going to my session, first I would like to show how many active users. So can anyone tell how many active internet users, how many videos will be uploaded in the YouTube? So all may be available in internetlifestats.com. So when you see this particular website, you can understand how many users retrieving the data from the internet, as well as the total number of websites throughout the world, and also number of emails sent today. Here you can see within a fraction of seconds the data will be changed, and how many viewers searching the information from the Google, as well as number of blogs posts written today, and the tweets, as well as number of videos viewed, uploaded, Instagram, so many social media posts, the internet connectivity, how we can upload all these analytics, how we can do this. So because of this machine learning and data analytics. Okay, so on to my presentation. Here you can see the data science job market trend analysis in 2021. So in the first chart, you can observe the various companies actively recruits data scientists. So Accenture having the highest percentage to recruit more number of people as a data scientist, and the next place goes to Amazon. So the least one is Arkle. So all these are various companies actively recruited data scientists. So when you coming to the second chart, you can observe. So most of the companies recruited the data scientists with an experience of 5 to 10 is more. When coming to 1 to 4, 2 to 5, and 2 to 4 years is very less. And also, this is here you can see most of the uh, uh, topics. What are the different topics like demand skills for a data scientist? Top 15, out of which Python, Tableau, all these are having highest demand. In a similar manner, these are the job roles for a data scientist. So like senior data scientist, lead data scientist, associate data scientist, there are various job roles we have in a data science market. Okay, so let's move on to the next slide, that is the relation between, what is the relation between data, information and knowledge. So let's see what is a data. So data is nothing but raw facts and figures. So that is nothing but before processing. What is in your hands is nothing but data. There is no meaning in that. Like for example, when you consider some Bharati, some 4002, like that, all these are data, but there is no meaning in that. We can some values, that's it. So when you coming to information, is nothing but the data which has been processed. So you are processing the information for what purpose? To get a knowledge. So you are applying some rules in order to understand or interpret it. So that we can call it as knowledge. So after processing information, after processing the data, you get an information, but you can apply some rules to that information, you can derive the knowledge. So for example, when you consider roll numbers, Y20, 70, 41, 001, some Y20, 31, 30, 41, 062, like that, some data. There is no meaning in it. So when you process, when you get information, that is nothing but select star from ANU results. We are affiliated to ANU, so that ANU results is a database, for example, where roll number is equal to something. Then you get the results of that particular 001 will be displayed. That is nothing but information. That is nothing but you are processing the data. When we get a knowledge, so when you look at this roll number, so Y20 is nothing but the student admitted in the batch 2020 to 2021 academic year. Okay, so the student joined is year 20. So when comes to 7, so 7 represents he is a science graduate. When coming to 041, it is our college code, SKBR Government Degree College, and 001 is his roll number. Okay, like that we can apply some rules so that we can understand the particular student belongs to in which group, in which college, at what time he will be admitted into that particular course. Okay, so this is nothing but the relation between data, information as well as knowledge. So coming to different types of data formats. Okay, so always when we discuss with data analytics, the terms structured, semi-structured and unstructured data often get discussed. So when you see here the visual pictures, so structured, XLS, DBF, CSV files. When you consider semi-structured, one email, one XML document, one doc file. When you coming to unstructured, one audio file, one image, one video file, like that. Okay, so what it means? So coming to structured data, the name itself says, so it is a structure. So it has a predefined data model. So that means the data is stored in a predefined data model, that is nothing but in a tabular format. So the information must be stored in rows as well as columns. So here the structured data will be stored in a rows and columns. So there is no random data. Rows and columns are related to one another. For example, when you consider Excel, so there are some sort of rows and columns. When you consider SQL, you can create some tables. There is also some information that we can call it as structured data. So the examples for structured data are policy data, client data, customer profile. For example, customer having customer ID, customer name, so customer address, phone number, like that, everything can be stored in the form of rows and columns. Then we can call it as structured data. So when coming to unstructured, quite opposite. So there is no structure. Unstructured in the sense there is no structure. That means some irregularity, some ambiguous. So there is no predefined data model for this type of data, like videos, audios, images, everything. So there is no proper specific structure for this. So for example, when you consider social media data, some Facebook or some anything you can consider. So it has some textual information or images or some videos are circulated, everything can be. Some insurance application, when you consider an insurance application, we are uploading our photos, some signatures, some phone number, like that. So all these are unstructured. When it comes under semi-structured, it is combination of both structured, sometimes we can unstructured. So like emails, XMLs, all. When you consider an email, for example, in the email, in the first field you can observe to CC, BCC. So all these are stored in a tabular format. So to whom you have to send a mail? What is the recipient address? And then if you want to mention CC, you can mention it. If you want to send BCC, you can mention it. If you want to write a subject, you can mention it. And you want to write any mail, compose it. And when you consider an attachment, so that may be, sometimes you may attach a PDF file, sometimes you may attach Excel file, sometimes you may attach video file, something, whatever it may be, okay. And also when you consider health records, they are also not structured, because sometimes we can have tabular data of patient data, but sometimes it has some X-ray information, ECG information, like that. So that's why we can call them as semi-structured data. Next one is data analysis. So why it is required? So what is the need of data analysis? Why we need to analyze the data? So the data analysis is nothing but process of examining the data to find facts, relationships, patterns, insights or trends. So that is nothing but you are analyzing the data. When you consider a social media sites, for example, e-commerce sites, like that, when you observe this particular item will be sold many number of times, many number of users are buy this particular item, like that. Sometimes the movie recommender system, the movie how we can rate 4.5 movie or 3.3 rating movie, like that, okay. So in the similar manner, based upon the data, we can process it first and examining the data. Why we have to examining the data? Because we need to find the reality and we need to find the result. For what purpose we are doing this analysis? To support better decision making. So we want to take any decision. Based upon these results, we need to do analysis. Without analysis, we can't get proper decision making. So for that reason, we are doing data analysis. So sometimes data may not accurate, may not be directly useful. Based upon the raw data, we are converting it and also doing some decision making. Okay, for example, here you can see ice cream sales. So here you can see ice cream sales as well as the weather. What is the factor depending upon the ice cream sales? That is temperature. Here you can see when 30 degrees below, 40 degrees, 50 degrees, 60 degrees, like that. So for example, an ice cream seller wants to store some ice creams to sold for the next day. How he can estimate how many ice cream cones can I get from the shop? So it's based upon the temperature. For example, if the temperature is below 30 degrees, no one shown an interest to take an ice cream. So it completely depends upon the temperature. So based upon the weather reports, I can predict the sales of an ice cream. Okay. So in order to determine how the number of ice cream cones sold is related to the daily temperature. Okay. If the temperature is high, automatically the sales are also high, because during summer more number of ice cream cones are sold, but in winter maybe less. Okay, so for that reason we need to analyze it. So for every analysis of information, we need some key factors. So first you should identify those key factors. Based upon those key factors only we can predict or we can take a decision. Okay, so for example, before for tomorrow I want to take some number of ice creams, then how I can identify tomorrow's weather report I will take, and then I will buy that number of cones. Okay, like that the result of an analysis would support decisions related to how much ice cream a store should order in relation to the weather forecast information. Okay, so the next one is data analytics. So is there any difference between data analytics and analysis? Yes. So analysis is nothing but detailed examination of the elements or structure of something. But when you coming to analytics, is a systematic computational analysis of data or statistics, where you are observing or you can observe the structure or something, that's it. But analytics, you are applying some computational or statistical tools to get a future prediction. Okay, so data analytics is nothing but a discipline that includes the management of the complete data life cycle. So it includes various phases like collecting the data, cleaning the data, organizing, storing, analyzing, and governing the data. So the term itself includes the development of analysis methods, scientific techniques, and automated tools. So data analytics is nothing but your process of exploring the data from the past. So from the past you are exploring the data. For what purpose? To make appropriate decisions in the future by using valuable insights. So it gives a better decision making when compared to analysis. So in big data environments, data analytics has developed various methods to allow data analysis to occur through the use of highly statistical distributed technologies and frameworks in a large volumes of data from by getting large volumes of data from different sources.
మనకు మెయింటైన్ చేయాలి అంటే గూగుల్ మెయింటైన్ ద ఓఎస్ఏ రిఫరెన్స్ మోడల్ అంటే సెషన్ అంటే ఆల్మోస్ట్ టాప్ అండి. నెక్స్ట్ మనకి ప్రెజెంటేషన్ లేదండి. నేను ఇచ్చిన డేటా ఏది డేటా సెట్ చేసేటప్పుడు
Now let us see what are different types of data analytics. Okay, so we have different types of data analytics. So the first one is descriptive analytics. That means by applying descriptive analytics, you know what's happening in that particular model. The next one is diagnostic analytics. So that means why it happening. In the predictive analytics, you know what's likely to happen. And the last one, that is prescriptive analytics. In that we know what do I need to do. Okay, so in the descriptive we know what's happening in that. In the diagnostic phase we know why it's happening. The predictive we know what's likely to happen. And finally in the prescriptive analytics, what do I need to do. Let's see one by one. So in simpler terms we say description about an event. So in the descriptive analytics, you can carry out to answer questions about events that have already occurred. So this form of analytics data is processed to generate information. So some sort of sample questions on descriptive analytics are: what was the sales volume over the past 12 months? If you have some sales data, then what is the descriptive analytics for that particular sales data? You know about thus how many sales done over the past 12 months, or else some other, what is the monthly commission earned by each sales agents. Sometimes some sales agents we want to give a best salesperson. At that time we can take how much commission earned by each sales agent. Like that we can get some sort of information. All those information we can get by using this descriptive analytics. Here you can directly take the information from the given. Okay, so that's why we can say what's happening in my business. We can say in any particular business you can consider it. You can see what's happening in my business by taking some sample questions. So in the similar manner, what is the number of support calls you are receiving as categorized by severity as well as geographic location. Okay, so like that you can get some sort of information. Okay, for that reason we go for descriptive analytics. Okay, so coming to diagnostic. So as I already told that it is nothing but why is it happening. So that means what are the causes to happen for that particular event. So the diagnostic analytics is designed to determine what is the cause of a phenomenon that occurred in the past using questions that focus on the reason behind the event. So what is the reason? We have to take an assessment of the descriptive data, and we are choosing some diagnostic analytic tools so that an analyst drill down to find the root cause of a problem. So when you consider some business information dashboards, you can see time series data, like how this particular data will be previously something, but now the data is fall down, the sales are fall down. Like that you can see some information on a dashboard itself, or weather forecasting. Like that we can observe based upon the information you are getting in the descriptive analytics. You can apply some diagnostic analytical tools so that you can identify the root cause of your problem. So why it's happening, what is the reason behind that, you can identify by using this diagnostic analytics. So for example, you can observe the sample questions on diagnostic analytics. Why were Q2 sales less than Q1 sales? For example, the Q1 sales are 900, but Q2 sales was only $800. So that means the Q2 sales are very less when Q1 sales. Why? What is the reason behind that? In the ice cream sales also you can observe. Suppose for example in summer it has $1,000 profit, but whereas coming to winter it has only $500. Why? Because of the weather. Okay, like that what is the reasons we have to identify. We have to identify the reasons. Okay, next. So why have there been more support calls originating from the eastern region than from the western region? Suppose in a telephonic place, some of the people observe. Why? What is the reason? There may be a festival, there may be some other thing. Okay, that's what we have to identify the cause, why it will be happen. So for that reason, we are moving to diagnostic analytics. In the similar manner, why was there an increase in patient readmission rates over the past 3 months? So this diagnostic analytics provides more values than descriptive analytics, but it requires more advanced skill set. When descriptive analytics, you have only the information, that's it. Whether the sales of Q1, what are the sales of Q2, what are the sales of over last 12 months, like that you get only the information, but you don't have any idea or any reason behind that why it happens. Okay, what is the cause to happen this particular decision or a business, like that you can't understand in the descriptive, but in diagnostic we can diagnose the problem. So the next one is predictive analytics. So predictive is nothing but what is likely to happen. What is likely to happen, that means what is the outcome of an event in future. In future, what is the outcome? Okay, so in predictive analytics we can carry it out in an attempt to determine the outcome of an event that might occur in the future. So but in observe diagnosis we can observe why it is happening, but here what is likely to happen in future, what happens. So for example, Q1 sales are lesser than Q2, then what is the sales of Q3? Maybe the past records may be useful to generate future predictions, isn't it? So with predictive analytics, information is enhanced with meaning to generate knowledge that conveys how the information is related. So, and also here you can observe the strength and magnitude of the association form the basis of models that are used to generate future predictions. So, which are used to generate future predictions based upon past events. Okay. So, the last one is nothing but it is important to understand that the models used for predictive analytics have implicit dependencies on the conditions under which the past events occurred. We have the result of past events. Based upon that only we can give the future prediction. This is all about forecasting. So whether it is the likelihood of an event happening in future, or forecasting a quantifiable amount, or estimating a point in time, in everything. So in predictive models we are simply utilizing variety of variable data of the past to make the prediction. So in a world of great uncertainty, be able to predict, want to make better decisions. At that time we use predictive models. These models are most important to give better prediction. So most of the business companies are also used these predictive models. For example, when you consider what are the chances that a customer will default on a loan if they have a missed monthly payment. For example, a customer missed a monthly payment. What is that? Is there any chance to that particular customer? So or else, if for example, if the patient survival rate, what will be the patient survival rate if drug B is administered instead of drug A? So actually if the patient survive, we need to give drug A. Now I want to examine if instead of drug A, I want to give drug B. So I want to also predict some information. Okay, so actual survival is drug A. But instead of drug A, can I give drug B? So that will also is nothing but one of the prediction. That is nothing but outcome of that particular event here. In the similar manner, if a customer has purchased products A and B, what are the chances that they will also purchase product C? Sometimes most of the people purchasing washing machine and refrigerator like that. So and micro oven like that. Suppose if similar electronic home appliances are purchased by some customer, there is a chance of purchasing one more product related to that particular home appliances. Okay, so like that we can predict it. So and the final one is prescriptive. So that means what do I need to do? Now what do I need to do? Okay, so this is based on the results or actions should be taken. So in prescriptive analytics, we are taking the results of predictive analytics by prescribing actions that should be taken. Here the focus is not only on which prescribed option is best to follow, but why we should follow. So in predictive analysis, we are getting some this one is better for future. So in prescriptive, we can take a result. So when we do this particular, what is that action? Okay, like that we are getting. So this kind of analytics used to gain an advantage, or sometimes it may be a risk. So this is sometimes we can take a traffic application also. So best route for home and taking into account the distance of each route, and also one person travel from one road to other road based upon the traffic constraints. Sometimes it may take 10 minutes time, sometimes it may take 15 minutes based upon the traffic. In addition to that, there may be some results to be added. Okay, so for example, when you take in 3 drugs, which one provides the best results? So when is the best time to trade a particular stock? So these maybe sometimes we can't say exactly. So that's why I'm saying this kind of analytics can be used to gain an advantage. Sometimes it may get a risk. Okay, we can't identify properly. So now let's see what are the applications of data analytics. Okay, so till now we are seeing various types of data analytics. Okay, now we can see what are various applications of data analytics. So the first and foremost application is spam detection. This is very good example of data analytics. So everyone having a Gmail account, so in that everyone see some messages are spam, some messages are genuine, some messages can be sometimes when we send some messages to our friend, sometimes they may be sent to their spam folder. Okay, so how all these can be done? Because of using some machine learning techniques. Okay, so there is some machine learning algorithm we are applying. Okay, so an email, some you are applying some machine learning model, it will identify. So if it is thoughts that is spam, it will enter into spam folder. If it is genuine, then it will enter into their inbox. Okay, so what are the factors of spam detection? So most of the research find that recipient address not into or not in CC field, then it will be 64% of transferring the mail to spam. In the similar manner, to field is missing, then also it will be 34%. And also sometimes CC field contains more between 5 to 15 recipients. At that time it is a chance of 3% moving to spam folder. In the similar manner, a field contains more than 15 recipients, it will be having 17%. Like that, these are some spam characteristics. Based upon that, the percentage of researched mails. Okay, so coming to next application, that is customer segmentation. Sometimes we need to segment customers based upon geographical regions or demographic information or something behavioral information like that. Okay, so given the pattern of behavior by a user during a trial period, and also take the past behaviors of all users, identify those users that will convert to be paid version of the product and those that will not. Okay, sometimes we may be identify. So based upon some information, we can identify this particular customer will, or this particular customer will not pay. Like that, we can segregate it. So in the similar manner, the next application is product recommendation. So product, in the product we may take in product or movie, whatever it may be. So data analytics or machine learning is the best suitable for recommender systems. So when you given a purchase history for a customer and a large inventory of products, and also you have to identify the products in which the customer will be interested or not. So the customer will be interested to or likely to purchase that product or not. Okay, so we have to recommend to the product to the customer. So how we can give? Based upon the customer purchasing history. Previously, so many customers are interested to buy this particular item, so that we can give the information based upon that. So product buying the uh, purchasing of product is most important feature for the customers, because by that rating only they are interested or likely to purchase. So product popularity based system is mainly implemented to target the new customers. Sometimes the customers, when you sometimes the new customer wants to buy or purchase anything from the internet sites, they have to see the previous customers history. Sometimes we may also see the reviews of the customers, previous customers, how they are feeling after buying this particular product, whether we want to buy it or not. So without when a new customer without any previous purchase history visits the e-commerce websites for the first time, he or she is recommended the most popular product sold on the company's website, but he wished to make that purchase. The recommender system updates and also recommend some other products. Sometimes when you view some particular item, if you are not buying that product at that time, but you can view that particular product for buying in the next time also. So this is nothing but a model of the decision process. So to the customer, to motivate of purchasing a product. So Amazon has this capability. So it has a better product recommender system, and also when you consider Facebook, Google Plus, all these are also recommended users to connect with you after you sign up. When you see Facebook, you can see other friends you may also in your list. You want to add a friend like that. Okay, so that is also given. So this is based upon how the recommender system will work on product recommender system, based upon the brand positioning, based upon the brand name selection, or brand sponsorship, or brand development. So like that. So and what there are different key factors we have. Based upon that, we can promote the product. So this is one of the best example of applications of data analytics. So that is medical diagnosis. So sometimes we are having a symptoms of the particular patient, and you have also a database of anonymized patient records. So based upon all these, you are predicting whether the patient is likely to have any disease or not. So based upon the examination, so the examination of the patient records gives whether that particular person having a disease or not. You are also here also you are diagnosing some disease. Okay, we are diagnosing the disease. So in this model also we are giving some decision. So what is that decision? Whether the patient is likely to have a disease or not. So here I am taking one example from Cleveland heart disease data sets. Okay, here you can see. So Cleveland heart disease data set, it is available in archive.us data set. So in that, here you can observe 14 attributes they are taking to find out heart disease. So in this data set, you can observe the attributes: age, sex, CP, that is chest pain time, blood pressure, cholesterol, fasting blood sugar, resting ECG, TLH, induced angina, old peak, slope, CA, TAL, concept class. All these 14 factors causes the heart disease to any patient. Okay, so these 14 information they are collecting. So, and this is the patient IDs 1, 2, 3 like that, and they are taking 14 factors. The 14 factors I am arranging as a columns. So first column having what is that? Age. Second calling, what is that? Sex. That means one represents he is a male patient, and 0 represent he is a female patient. Okay, so like that we can store 14 information. For example, here the third, what is that? Chest pain type. So 1 represents typical angina, 2 represents atypical angina, 3 represents non-angina pain, 4 represents asymptotic chest pain type. So we have actually the different chest pain types. There are categorized into 4: typical, atypical, non-angina, asymptotic. So for that we are giving some values. So always better to deal with quantitative data rather than qualitative data. So qualitative is nothing but it is a textual information, textual description of a data. When you deal with quantity, you can statistically get some information. You can rigorously work on it. So when we deal with the qualitative, so for example, when you want to find any product information, sometimes some people are giving the review as good movie, better movie, super movie, like that, some information that is nothing but qualitative data. So by using that also we can do it, but when we want to diagnosing or when we want to analyzing some information, you should always seems to be the information must be in a quantitative manner so that you can retrieve the information in an easy manner. So that's what I am giving. Cleveland heart disease data sets are giving us. There are 4 different types of chest pains, so that the values are, they are giving 1, 2, 3, 4. So 1 is typical angina, 2 is atypical angina, 3 is non-angina, 4 is asymptotic. Like that you can give the values. When you consider the 4th column, what is that? So blood pressure. So upon hospital admission, what is the blood pressure of that particular patient? So like that you can note down. So for the first patient, second patient, third patient, like that here we are representing. In the 5th column we are observing cholesterol. So cholesterol is nothing, serum cholesterol in terms of milligrams. So coming to the 6th one, fasting blood sugar. So above 120 grams, then 1, otherwise below, if it is below, there is no sugar, that's why we represent it as 0. So based upon that, here the column values you can observe 0 or 1. 1 is nothing but that patient has diabetes. So when you consider 0, that means that patient has no diabetes. Okay. So in the similar manner, when you consider the 7th column here, when you observe it, which is nothing but resting ECG. So which is nothing but electrocardiographic results. There are 2 different types of values, 0, 1, 2. So 1 is normal, 0 is normal, 1 is STT type of electrocardiography. Okay, like that we are giving the values. In a similar manner, here you can see what is the maximum heartbeat rate of that particular. All these data when we are collecting at the time of admitting into an hospital. Okay. So in the similar manner, when you consider the 9th column, you can observe, does the patient experience angina as a result of exercise? So, and also when you consider 10th, whether the particular patient having any depression. When you consider, so 11th column, it is nothing but slope of the peak exercise, and 12th, when you consider number of major vessels colored by fluoroscopy, and the 13th one normal, fixed defect, reversible defect, like that, and the 14th one is angiographic disease status. So all these are the key attributes when we want to find medical diagnosis. So this is the best example of Cleveland heart disease. When you type in Google also, you can get this data set. By using this data set, we can identify the rate of heart disease, the prediction of heart disease. So actually it has 76 attributes. So in each and every data, once remember that in every data analytics phase we have huge amount of information, but we don't want to take all those informations. You need to take what are the required features or factors to predict the future. So not all the data is useful. So you need to identify it. First you need to analyze it. So out of all these, actually when we diagnosing heart disease, we have 76 attributes, but out of which most of the identification purpose, most of the researchers use these 14 are suitable attributes to find that particular patient getting a heart disease or not. So most of the people are also used naive Bayes was the best algorithm to predict whether that particular patient having a heart disease or not. So this is the best application for data analytics. We can collect so much of information, but out of which we can retrieve few of the attributes. Based upon that, we can predict it. So the next one is speech understanding. This is the best example we are all use nowadays. So give an utterance from a user. Identify the specific request made by the user. So what are the requests made by the user? The machine can do it. For example, in your phones, in the iPhone Siri, in the Google also, Google Assistants. So all those are, when you see my child also, my son, Google open file manager, then automatically in my phone, the file manager folder will be opened. So this is nothing but we are designing a model that would allow a program to understand and make an attempt to fulfill our request. So we are requesting something. So in your phone you observe. So when you press Google Assistant, when you call Google Assistant, simply, hey Google, open YouTube, then it will automatically move on to YouTube. Okay, so like the speech understanding is also one of the best application. Okay, so the next one is desert recognition. So desert recognition, in the sense we have some sort of zip codes, handwritten envelopes. We can identify the digit for each handwritten character. Actually we are written in a hand. That handwritten character is identified by our model, so that the envelopes are based upon the geographical regions. So the next one is shape detection. Sometimes the users draw shapes on a touch screen, so that the database understands the shapes what the user was trying to draw. So this is also a model which allows a program to show the platonic version of that shape the user drawn to make crisp diagrams. Okay, so sometimes we are using also different shapes. For that also we are using this detection. Next, the last but one is data life cycle. So what is data life cycle? Why it is important? So in data analytics, we need, or we design, or we try any model we need a data life cycle. So in the project also, when we want to build any project, we need some sort of phases, isn't it? So when you want to design any software, you are having some requirements gathering. After that, you are designing. After that, you are coding. After that, you are implementing. After that, you are testing, and finally get their outcome. Okay. So like that also, when we move on to the data analytics, we are also having a life cycle. Okay. So the data analytic life cycle was designed to address big data problems and also data science projects. To address the specific demands for conducting analysis on big data, the step-by-step methodology is required to plan the various tasks associated with the acquisition, processing, analysis, and recycling of data. So it is very useful. So in that, here you can see the life cycle. So the first phase is data discovery and data preparation, model planning, model building, operationalize, communicate result, and finally if again anything happens, it seems not to be okay by the customer or end user, then again we want to discover what's happening. Okay, so it is a cyclic process. In any stage something happens, we will move on to again previous stage. When you observe in model planning, we want have something, then again you can get back data preparation. If anything happen, again I am go get back to discovery. Like that we can move on from one phase to other phase. So in the first phase of data life cycle, the phase 1 is discovery. Here you need to understand the various specifications and what are the requirements, priorities. So as I already told in the medical diagnosis, where there are 76 attributes, but out of all which only 14 are important. So that is nothing but prioritize. So what data is giving that particular insight, you should analyze it, not complete data. You are not taking all the data. You should sometimes you should analyze it, which one is useful. Okay, so like priorities, some required budget, like that what we need to take. You must possess the ability to ask the right questions. Without having right questions, you can't move on to the next stage. You have a clear cut specification. What is your requirement? What do you want to do? What model you want to build? So you have a clear cut idea. So for this, the required resources are people, technology, time, what type of data is needed to support this particular project, like that. Okay, so in this phase you should frame the business problem. So what is the problem you want to, what is the model you want to design? So you question yourself. So you frame the business problem and also formulate the initial hypothesis to test. So in this discovery only, the data science team researches the issue. So that only, without researching issue, we can't frame the problem. So we can create we can identify some problem. Further, we can create this particular context by using these specifications, by using these requirements. With the help of these technology, we can develop this particular process. That is nothing but initial hypothesis. So that can be confirmed with an evidence later. So first we need to initiate we need to formulate the initial hypothesis. Then only we can confirm with an evidence. So the next phase is after discovery. You are discovering something. I want to do something. So I want to develop a model for mango fruit detection. Like that, you can identify your problem. After that, you should prepare your data prior to modeling phase. So here you can see, prior to modeling phase, you should do preparation. You should prepare the data. So for that, you need to do extract, preprocess, transform, load and transfer. So this is nothing but, this process, this phase is nothing but process of transforming raw data so that data scientists or analysts can run it through machine learning algorithms to uncover insights. So why we use this phase? So you need to identify missing or incomplete records, or you can spot the outliers, or improperly formatted data, is there anything, or you can establish a relationship between variables, or sometimes inconsistent values, like for example, sometimes you may write DBMS, or sometimes you may write database management system. So some inconsistent values are also placed. Okay, so the data preparation stage helps the developer to spot the outliers or missing or incomplete records or improperly formatted information. Everything can be identified in the data preparation stage only. So when you observe here, preparing the analytics sandbox, then it will performing ETLT. So ETLT is nothing but extracting, transforming, loading, again transform. That means you are ensuring data quality as well as securing sensitive data. So you are integrating data by performing ETLT. So when you are extracting, that means the raw data or unprepared data. You are collecting raw or unprepared data from the source applications. That is nothing but you are getting some information. Then after that you are transforming. That means you are taking the data and you can cleansing the data or you can masking the data, something. And load is nothing but you are preparing the data into data warehouse. And the last T, that is transform, that is nothing but you are integrating the data more completely within your data warehouse. That is nothing but you are integrating multiple data sources. From multiple sources you are applying something. So this ETLT allows you, the user, you can ingest data from diverse sources in a faster manner. Okay, so after that you are applying some techniques, and then finally you get a survey and some visualization or something we can get in. Okay, so in the next one is modeling phase. So modeling phase is nothing but you are develop a model. So when we want to developing a model, you need or you have to identify some methods and techniques, because you want to design a model. For that reason, you should identify the relationship between the variables in your data. So in the previous stage, you are cleansing. So you are missing data, whatever you are identifying and cleansing. So now you should apply some techniques or methods to pay or to grab the attention or to grab the relationship between the variables. So for that you will apply various statistical formulas or visualization tools, for example by using R or Python, Tableau or whatever it may be. By using those, you can identify it. Okay, so you can here you can find a suitable model for your project. So and also you can deploy the planned model in real-time environment. Your aim is nothing but you are forecasting your decision and customize the market strategies and develop a tailor-made model. So in this model, we are not directly design the exact or perfect model. It is a tailor-made model. This can be done by integrating the model into your existing production, or you may design a newer thing also sometimes. Okay, so in this phase, you have to take, or you have to pay a more attention on the relationship between the variables of your data set. So in the fourth phase, that is nothing but model building. So in the previous one, we are only the modeling phase. This is this one. So we are determining, or you are taking a conclusion of the relationship between the variables. But in model building, you have some existing tools. Based upon that existing tools, you are running your model. So for that, and we are trying the model, as well as we are testing that model by taking some sort of data sets. Always when you are taking the data set, 100 images you are taking, in that 70% of images are used for train, and the remaining 30% of images is used for testing. So here in the model building phase, we are defining, so these images are used for training purpose, and these images are used for testing purpose. Like that we can analyze it. And also we are applying various learning techniques, some classification techniques, association rules, or clustering to build the model. So when you consider classification, which is nothing but a data mining function. So the main goal of classification is accurately predict the target class for each case in the data. You are classifying the model, that is nothing but you are identifying the low, medium, high risk. You are classifying the information. Okay, so by using the classification, we are predicting some information. So in the model building, we are trying as well as testing data sets. Both are created, and after that we are using some existing tools or some learning techniques we are applying to get in to predict the future information. So in the fifth phase, we are visualizing. Visualizing in the sense we are delivering the final products. So normal information we can't identify, or we can't see the proper insights. When you in a visualization, you are interpreting the information in visual terms. That is nothing but you are representing information in the form of images, diagrams, animations, or whatever it may be. So you are delivering the final products, you are coding, you are preparing technical documents, you are briefing the information, and also you are provide a clear picture of your performance and other related constraints on this particular deployment. So in the sixth phase, that is communicate results. This is the last phase. In that you are identifying all the key findings. What are the key findings in that? And also communicate to the stakeholders, and also determine whether the results of the project are successful or failure based on the criteria developed in the phase 1. So first, once doing all these stages, we can finally, we have some key findings, and we have the final end product that we have to communicate to all the stakeholders. Stakeholders may be your employees, your co-friends, or customers. So all those are comes under stakeholders, so that you can communicate with them. And then you determine whether the project is successful or failure. So if it is successful, there is no need of going back to phase 1. If it is failed, then again you should go back to phase 1, that is discovery. So is there any backlog in taking of priorities? Is there any other requirements to fulfill this particular model? Like that, again you can get back. From that, again you can prepare your data, modeling and model building, visualizing and communicate. So all this is a systematic approach. So further it is nothing but you are doing step-by-step methodology. Why? Because you want to design a model. If you want to design a model, there is a need of step-by-step process. Without step-by-step process, we can't do anything in a proper manner. We are doing step-by-step procedure. The last one of this seminar, this session was case study. I am taking the case study is diabetes prevention. So no model is 100% perfect. So here we are trying to prevent diabetes. We are not curing. Remember that. We are always, when you want to design any model, that is nothing but it is not cure and it is not a 100% accuracy. So it is, we are finding the occurrences, or we are predicting the occurrence of diabetes. Is there any chance to occur diabetes to a particular person? And also you can take appropriate measures. Sometimes the patient doesn't have any diabetes, but there may be a chance to getting a diabetes in future. At that time, you have to give appropriate measures beforehand to prevent that. Okay. So there is, in any disease, when you consider, there is no cure, but there is a prevention model. So that's what here we are doing. So what if we could predict the occurrence of diabetes, and we have to take appropriate measures beforehand to prevent it. Okay. So both cases we are doing. So we are finding, or we are predicting the occurrence of diabetes, as well as we are taking the appropriate measures before that to prevent the diabetes. Okay. So first, so in previous we are seeing, so what are those? When we want to do, or when we want to develop any model, you need to discover the data, preparing the data, model building, visualization, communicate. So the same thing here apply. So here I am giving the site, or else you can download in Kaggle also. Okay, Kaggle nowadays most of the people use Kaggle data sets. You can collect data from that also. Okay. So in the first phase, first you need to have a diabetics data set. So I am taking this diabetic data set from archive.icsuca.edu. In that machine learning, I am taking these data sets. Okay, you can see that there are huge number of data sets related to healthcare or product recommender. So many data sets are there. Okay. So in order to find the medical diagnosing the disease of particular patient, we need have the medical history of that patient. Without medical history of that patient, we can't give some conclusion. For example, whether that person having any sugar or I mean blood pressure earlier, or what is random blood sugar at that time, like that so many causes we can collect it. So the medical history of patient is very much useful when you want to give any conclusion. So here we are taking 8 key attributes: that is number of times pregnant; glucose, that is plasma glucose concentration; and BP, blood pressure. Next, skin, triceps, skin fold thickness. This is also one of the attribute useful to diagnose the patient having a diabetes or not. So, and also one more is body mass index, and the next one is diabetes pedigree function. And what is the patient age? Sometimes you may observe the child having 3 years is that child is also having diabetes. Okay, so the age is also a key factor to identify the patient having a diabetes or not. So there is no age gap nowadays. And income. So out of all this, income feature is not necessary, but sometimes some researchers identify if the person having higher income, they are addicted to eat junk foods. They are enjoying most of the time. When you are some researchers only focus on this key factor, income. If the person's income increases, or if the person wants or tries to get more income, he gets stressed by doing more work. That is also taking as one key factor. So, but in this our problem, we are not taking income as a key factor. The remaining 7 factors we will consider. Here I am taking the dataset values: 21 patient records, number of times pregnancies, glucose, blood pressure, skin, body mass index. Okay, like that we are taking all the information. Now this information, this is .csv file. This information you can in the next phase. Okay, we are collecting the data only. Okay, here in the step 1 we are collecting the data, that's it. So once after collecting the data, the second step, you need to clean the data and prepare the data for analysis. What is the meaning of cleaning? So cleaning is nothing but you are identifying missing values, blank columns, incorrect data, inconsistent values, improperly formatted values. So you need to find all these type of values in your data. So you need to clean the type of missing values, blank columns, inconsistent data, improperly formatted data, unexpected values, incompatible values, like more different types of inconsistency in the data. So you need to identify those data first. After that, you need to clean all that type of information and prepare the data for analysis. Now you are preparing in this step 2, you are preparing the data for analyzing. Why we are analyzing? To make a decision. So as I already told, the data analysis is nothing but you are examining, that's it. But in the analytics, we are applying computational analysis, systematic computational analysis. So only in analysis phase you are understanding the data and what are the required insights from the past, what happened so far, like that we are identifying. Okay, so that's why we are cleaning the data which we have taken as a source and prepare that data for analyzing whether that particular patient having a diabetic or not. If not, is there any chance to prevent, is there any chance to getting diabetes, then we can give suggestions to prevent it. Okay, so here you can see, so this is a table. In this table you are see some inconsistency. So number of times pregnancies, actually here you have a figure 1, but instead of that you are getting a string ONE1. That is nothing but an inconsistent. So actually there we have to observe a numerical value 1. Instead of that we are getting a value ONE1. So that is inconsistent. In the similar manner, here there is no value, it is a missing value. So that is glucose. Okay, so plasma glucose concentration, that is not filled in that. And also when you consider BP, so is there any chance to having 6600 BP? Isn't it? Okay, so that is nothing but not an appropriate data. So there is here, this is a missing data. Okay, here this is not an appropriate data. This is improperly formatted, isn't it? When you properly formatted, in the sense here also you have the value 1. Okay, a figure 1, not ONE1. Okay, so that is nothing but improperly formatted, missing values, inconsistent. So the actual value is not that this one. Okay, and also here also we are observing some missing values, and we don't want to take income for the consideration. Now, so what we need to do here, we need to clean the data. So then these are the observations. So NPREG 1 is written in words, whereas it should be in the numeric like 1. So in column BP 6600, which is impossible. Human cannot get up to such huge value. Okay, so income value is blank, and it is also doesn't take to predict diabetes, as I earlier told. Okay, which is a irrelevant of data, so that it can be removed from the table. So, and also we will clean and pre-process this data by removing the outliers, filling up the null values, and normalizing the data type. So we will pre-process this data by removing the outliers. Outliers, as I already told, missing values, improperly formatted, inconsistent values, all those we can remove it. How can we can remove it? Filling up the null values as well as normalizing the data. So this is only a second phase, which is nothing but data processing. Once we can do all this, we get the clean data. So what the clean data? Like this one. So again we have to recheck it. So we have to recheck it. That is 1, ONE1 is replaced with 1. And also here you can see the masked value, null value is replaced with some 97. And here also the BP is replaced with 80. And also here value replaced with 38, that is triceps skin fold thickness. And also here the body mass index will be replaced with 39. So, and also I have removed the income column because it is not necessarily used in this model, because there is no necessary to take income as a one of the attribute to identify whether the person getting a diabetic or not. Okay, so that's why we can remove that column. Okay, so we are taking all these taking the database and we can identify inconsistency, missing, not formatted data, like that. We can identify all those. Once identifying all these, we can replace it with relevant information so that the data is clean and ready for processing. So this is nothing but data processing stage. So in the next stage, so in step 3, we load the data into analytical sandbox. Okay, and after that we are applying various statistical functions on it. Then we can use a describe function which will give the statistical information like mean value, median value, range, minimum value, maximum value. Like that we can identify it. Sometimes we can use histograms, some visualization techniques like histograms, line graphs, box plots, to get a fair idea of the distribution of data. So in the step 3, we can identify, so we can visualize some information. So in the first step, we are giving the data into analytical sandbox. The main goal of analytical sandbox is to enable the business people to conduct discovery and situational analytics. So that is nothing but it gives a standalone solution for capturing and processing large quantities of data from multiple sources. In order to perform analytics in isolation, then the enterprise data warehouse. Okay, you can. So, and we are applying so many statistical functions. So then you can get the information like what is the mean value, median value, and you can visualize the information based upon histograms like that. So the number of times pregnancies in this 75 members, some 50 members like that. So, and also you can observe diabetes pedigree function value before the value of 99.5, lesser than 99.5, greater than 99.5, like that. You can visualize the values by using this histogram. In the age group also, when you observe the ages from 21 years to 81 years. So in 80 years you may get one person, in some 75 years you may find one person, like that. These are the total number of people in this particular age group. Like that we can observe the histograms to analyze how many people are affected, are in this particular attribute, how many people are in this particular attribute. When you consider number of pregnancies, 6 times, 1 time, 3 times, 2 times, 0 time, again 9 times, 10 times, like that. So how many number of 9 times are there? 1, 2, 3, like that. Some 3 people, maybe in case some number of people are there, like that you can observe. So what is the values? Okay, so by visualizing the information, the textual information can't give proper or clear cut idea, but when you visualize something or when you visualize anything, anyone can understand easily. So step 4 is nothing but, now we are in the final stage. That means we are giving a decision. So decision tree model. So decision tree model is very useful to find the end result. So it gives an end result. It is used to find whether that particular person having diabetic or not, or else some other. For example, when you consider a cotton crop, so that crop having a pest or not, so that also we can identify by using this decision tree model. So decision tree model will help anyone to either email classification or else pest classification. For anything, it gives a better result. It is nothing but yours. You already know that it is a supervised learning algorithm. So it can be used for both classification as well as regression models. So it is mainly used to split the data based upon the attributes. We can split the data, for example, if whether you are taking a person having lesser than age 30 or greater than age 30, then you can come down to one branch or you can come down to another branch like that. So the tree can be explained by two entities. So decision nodes and leaves. So in a decision tree, we have only two branches, decision nodes and leaves. The leaves are the decisions or the final outcomes, and the decision nodes are where the data is split. So here you can see a decision tree model is a very robust, as we can use the different combination of attributes to make various trees, and then finally you can implement the one with the maximum efficiency. Since we already have the major attributes like number of times pregnancy, body mass index, like that we are taking so many attributes. So in this we are using supervised learning technique to build the model. So in our case, we have identified a linear relationship between an age group with a number of times pregnancies, whereas the non-linear relationship between, we have observed that number of times pregnancies with the number of times pregnancies with diabetes pedigree function. So for these two attributes there is no linear relationship, but age and number of times pregnancies there is a linear relationship. Here you can observe the decision tree. So for example, when you consider the key attribute is the root node. So as I have already told that, so in a decision tree we can explain the entire concept in a two entities. One is decision node. This is, here you can see decision node. So this is glucose. Here I am taking glucose as a decision node. So and the remaining entities like these are act as a leaves for this decision node. Again, this leaf may act as a decision node for the next. Okay, at the end of the decision tree we have only leaf nodes. So these leaf nodes gives the final outcome. So the leaves are the decisions or the final outcomes. But what about the decision nodes? Decision nodes are where the data is split. So here you can see decision nodes, I can represent it in blue color. So glucose, pregnant, age, BMI, all these are decision nodes. So based upon these nodes, where the data is split, we can identify. After that, the decision, we can get a leaf or maybe another leaf is a decision node. Again, you can apply supervised algorithm to that particular node. Again, it may be divided into decision node or it's a leaf node. Like that you can split. When you consider in this problem, so I am taking the root cause of this particular diabetes is glucose. So value of plasma glucose concentration. Okay, if that value lesser than or equals to 127, what are the chances of getting diabetes? If the value of glucose is above 127, then what is the chances, what are the chances getting diabetes? For example, here if the value of plasma glucose concentration is lesser or equals to 127, then we are taking one more decision node. Whether she is pregnant. Whether is she pregnant for how many number of times. Whether the pregnancy chances are lesser than or equals to 5, then or above 5, then it may getting a chance of diabetic. Or else if the pregnancy chances are lesser than or equals to 5, then we can consider it age group. So whether she is having a below age group 28 years, then we can check one more decision node we can take, that is body mass index. So and also again this body mass index is above 30.9, she may have diabetes. Here you can see the complete path. So if she is having a plasma glucose concentration is lesser than 127, and the number of times of pregnancy is also lesser than 5, and the age is below 28 years, and also the body mass index is less than 30.9, then there is no chance of getting at that time there is no diabetic, but there may be a chance. Okay, so there is no chance of getting diabetic. So here positive in the sense there may be a chance of getting diabetic, not a diabetic, getting a diabetic. We are preventing, we are building a model to prevent diabetic. There may be a chance of, here all positives represents there may be a chance of getting diabetic, not diabetic, because without random blood sugar RBS we can't say whether that person having a diabetic or not. So here we are trying to build a model of preventing diabetes. That means whether we are identifying whether the person getting a diabetic or not. So all these negatives indicates they are not getting diabetics. So all these leaves positive represents there is a chance of getting diabetics. Here also you can observe this part. So when the plasma glucose concentration is above 127, in that also again I am taking one more glucose plasma concentration which is above below less than 154, and the body mass index is below 30.9. So there is no chance. Here you can observe the glucose level is above 127, but again another glucose level is also above 154, then there is a chance of getting diabetes. But when you consider the body mass index, if it is less than 30.9, there is no chance to get a diabetic. But when it is above 30.9, there is a chance of getting diabetic. By using this supervised algorithm or by using these particular models, we are able to understand is there any chance to get a disease to that particular patient or not, so that we can take preventive measures. Okay, this is a preventive model, not we are finding this particular person having diabetic. Because we want to find a person having diabetes, we need RBS. Without RBS we can't say. Okay, so only we are taking some patients previous history. By using that we can analyze it whether the person having or getting diabetic or not. We are saying yes or no, that's it. If there is a chance, then that particular person taking precautionary measures, that's it. Okay, so I think it's clear. So you are taking one node as a decision node. So by using the decision node only, you can split the tree into two parts. Either sometimes you may split the decision node as a decision node, or else the decision node can be split as a leaf nodes. So always remember that the leaves are the final outcomes. So these last 10 leaves, terminal nodes, all the terminal nodes are the final outcomes. Okay. So sometimes the decision nodes is where the data can be split, whether for sometimes if age is less than 30, yes, he eats lots of pizza, unfit for the job, like that we can classify. Okay, so we can categorize the information based upon the decision root elements. Okay, so here I'm saying the important parameter is glucose. By using that, we can determine the next important parameter. So based upon that, the final leaf nodes are either positive or negative. So in the step 5, so step 4, we build a model, that's it. But our model is maybe a better model or may not be. We can't say because we are not tester. We are only builder. So always we have to test it after completion of the design. Okay, so kabatti here we are only designing the model. Now we are testing. How we can test? So we will run small test cases. So like results are accurate or not. We are taking so much of data and check all constraints. If suppose sometimes we are not getting accurate results, then again we need to replay it and rebuild it and again check it. Okay, so always remember that every model is the best, every model is not a best model. When you will run some small test cases, you can check the results, whether the results gives accurate results or not. If the results doesn't give accurate, then you are reassess, you need to replay and rebuild the model. And again, it is, you need to run small test cases. It is a cyclic process. Continuously you can do all these things. And finally, the last step, we have executed the project successfully. Then only we can share the output for deployment. Otherwise, we can recheck it, redesign it, recheck it, redesign it. So this must be a continuous cyclic process. So with this few words, I want to conclude my session. Data will talk to you if you are willing to listen. So if you are ready to willing to listen, the data definitely will talk to you, so that you can do wonders. You can listen, you can take the information, you can get the information properly, you can analyze it with an appropriate statistical, by applying some statistical tools, then only you get a beautiful insights. So be ready for listening, or if you are really willing to listen, you can do wonders with this data. So thank you very much for giving this opportunity.
Thank you very much,
Madam. I have some questions. Madam, I have some questions.
Yes, sir.
Madam, you told about the three things, the concepts that are covered under data mining. Like, Madam, you told in the seminar that in the session just now, you covered three concepts like classification and association, and as well as this classification, association, and the third concept, like this clustering. So these three concepts comes under data mining. So what is the role of data mining in data analytics, madam?
Yes, sir. In analytics, we are sometimes applying analytics in the sense you are getting insights. You are analyzing or you are examining your data. In the mining phase also, you are extracting the data. Here, in analytics, when you are a detailed examination, you are exploring the data from the past. So by using by giving some appropriate decision in the future. So we are also taking some techniques, tools which are useful in data mining can be applied in analytics phase also, because you are getting the result. You are getting prediction for the future. You want to try analytics in the sense you are predicting the future. For that also we are using data mining techniques also. Those are also part of subset.
Okay, madam. Madam, I didn't understand what is the data node. The difference between the exact difference between data node and leaf. Leaf is final outcome that I
Yes,
understood.
leaf is final
Then
outcome.
data node,
Data node is
madam.
decision. What is the decision attribute? Sometimes we are taking this attribute as a decision. For example, when you consider here glucose parameter, I am taking as a decision node. For example, when you consider obesity problem, then you can take some body mass index values. So at that time, BMI is a decision node. So that node will split into two parts. Again, it may be a decision node or a leaf. For example, here you can take it as glucose is a decision node. It will be splitted into one more decision node and one is leaf node. So it may depend. Decision node is nothing but what are the attributes, what are the parameters you are considering for making a decision.
Madam, what are outliers? Outliers is like
Missing values,
missing
or
values, abstract values, missing
inappropriate
columns.
values, whatever it may be.
Then what is pedigree function, madam?
What's that?
Pedigree function that you and pedigree function that you told in the just now in the session. What is pedigree function, madam?
Sir, it is related to, we are not applying any computers related function. It is diabetes one parameter. It is not any function related to our computer science.
Okay, madam.
It is collected information after checkups, while sometimes we are taking information from lab reports. So in that, one of the key factor, that is an attribute, not any function, computer science function.
Okay, madam. Madam, is there any algorithms that helps in detecting diseases, medical diseases, like for medical diagnosis, like for example, heart attack or diabetes or some other
Yes, so
people
many
suffering from
algorithms. So many
Alzheimer
algorithms
disease?
are available now. Naive-based algorithm, KNN, support vector machines. All these algorithms are used to predict the diseases.
Okay, madam. Thanks, madam.
Thank you, sir.
Thank you for your wonderful session, ma'am. Okay, dear participants, you have known so many things from madam, regarding madam concepts. Okay, tomorrow morning also madam will continue the session. We participate in the tomorrow's event. Okay, I mean that FDP. This FDP. If we have any doubts regarding madam session, clarify your doubts in tomorrow also. Okay, thank you, ma'am.
Thank you, sir. Thank you so much.
Okay, ma'am.
Thank you, madam, and thank you, organizers.
Okay, sir, we are posted your attendance link in the group, sir. Please fill it, sir. Please, all the participants will fill the attendance link. We posted already in the group.
ఇక్కడ కూర్చొని మహారాష్ట్ర స్టూడెంట్స్